Hi there, this is Penelope. This is the third in a series of short videos on trig equations. In this one, what we're going to do is we're going to look at how we can write sin 4t plus 3cos4t in 4 different ways. Now, you're only expected to be able to do the first one, and that is the formula that will be given to you in the exam, but it's a good thing to recognize how to do the other ways as well. So, we will have, to start off with, we need to find r. R is equal to the square root 1 squared plus 3 squared, which is root 10. Now that's the same for all of them. Now the first one, we're going to write it as y equals r, which we've just found, as root 10 sin 4t plus alpha. And in that case, alpha is equal to tan inverse of b over a. And if you look at the preceding slide, that says that that is tan inverse of 3 over 1. So alpha is equal to 1.249. So we can write y equals square root of 10 sin 4t plus 1.249, remembering this is in radians. The second way we might want to write it is y equals root 10 sin 4t minus alpha. In this case, alpha is equal to tan inverse of negative b over a, which gives you tan inverse of negative 3 over 1, which is negative 1.249. Putting that together, y equals root 10 sin 4t minus negative 1.249. And you can quickly see that actually that's the same as number 1. Number 3. Third way is to write it as root 10 cos 4t plus alpha, and in this case alpha is equal to tan inverse of negative a over b, which is tan inverse of negative 1 over 3, and using a calculator you get that that's negative 0.322, which in actual fact is the same as 2 pi minus that, which is 5.961. So y is equal to root 10 cos 4t plus 5.961. And if we do it the other way, the final way, writing it as y equals root 10 cos 4t minus alpha, I'm just running out of room. Alpha for this one is tan inverse a over b, which is tan inverse of 1 over 3, and that's 0.322. And if we put it all together, running out of room, that would be cos 4t minus 0.322. So now we've got, let's just identify them. We've got 1, 2, whoops, I'll write it over here, so here it is here, 3 and 4. I used Desmos for the next slide, and bearing in mind that 2 of them were the same, the first one, there were 2 versions of the first one that ended up the same, you can see there that each of those graphs is on top of the others, so that clearly shows that all of them are the same thing. We are just writing them in a different manner, and the reason that we write them in the different manner is the different tan inverses. So there's one. There's the second one. There's the third one. And there's the fourth one. Now, you are expected to know just the first one. This is the one here for the exam. And the bits for it will be given in your formula sheet. Okay, so just to show you the picture again, they are all the same. You can do this yourself to prove it. Put all of those separately into Desmos and it will give you exactly the same graph for all of them.